All right, so here is our first example that we are going to solve for x. It says 2x squared minus 3x minus 2 equals 0. Because we're using the quadratic formula, it's in our best interest to probably write that quadratic formula down. It's good for me to reference. If you have it on your notes already, then you know it. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me tell y'all something. Y'all are lucky because last year the kids had to give me this as part of their quiz. They had to say that every single letter, and if they got it wrong, they had to do it again. Just kidding. But that quadratic formula we need, so we're going to put it right here next to our example so it can always be something we reference back to. All right, cool. So first thing we talked about with solving this quadratic is we know that we are solving for x meaning our solution, x meaning what is this value when our y value equals 0. So our equation is already set equal to 0. So we are already in a great place. If this equation was not set equal to 0, we would have to solve for that, and we'll see that in the next example. Now that our equation is solved for 0, using that quadratic formula, like I mentioned before, we have b, we have a, we have c. We need to actually know what those numbers are. So if we remember our original standard form of a quadratic equation, ax squared plus bx plus c, okay, we can identify what our a is, what our b is, and what our c is. So we kind of make a key. A equals, b equals, and c equals. All right. My a value is, of course, in front of my x squared, and that is 2. My b value comes next. Remember, this is negative 3x. Okay, we take the sign with the number. And c, again, same, negative 2, because we take the sign with the number. Okay. Now we have those three numbers. We can manipulate this formula any way that we would like. I mentioned before about the discriminant. The discriminant is this b squared minus 4ac component, right? That tells us how many solutions we're going to be solving for. Because sometimes, if it says we have no solutions, then we don't really actually have to continue to solve using quadratic formula. So we're going to use the discriminant, and we're going to use green pen. And we are going to determine how many solutions does this quadratic equation have? How many times does it cross the x-axis before we actually figure out what those two values are? So the discriminant is b squared minus 4ac. What I always like to do when we're practicing substitution is to write out the parentheses that are going to be representations of the values we're going to replace them with. So b squared, b is negative 3, so I'm going to substitute negative 3 here, minus 4 times a. Our a is 2, substitute that there, and c is negative 2, substituted here in our last parentheses, okay? You can definitely use PEMDAS if you want to do this math on your own, in your head. However, you're more than welcome to use your calculator. Y'all know I got Charlie somewhere here. So I'm going to type in my calculator, negative 3 squared, negative 3 squared minus 4, parentheses 2, parentheses negative 2. And I get 25, okay? 25. So that is my discriminant value. Now, going back to the notes of what a discriminant is, as you can see here, our discriminant, if it's greater than 0, there's 2 solutions, equal to 0, 1 solution, less than 0, no real solutions. So our discriminant is 25. 25 is greater than 0, okay? Hopefully you agree with that. Because 25 is greater than 0, we are going to have 2 solutions. That means when our graph crosses the x-axis, it is going to cross twice. Might not be those exact numbers, but I want you to reference and see what that actually means, okay? Now that we have this discriminant value, 25, we are going to continue to solve for these solutions by using the quadratic formula, okay? So let's keep going. So I have the quadratic formula. I'm going to substitute that by just writing QF. This is a lot of words, a lot of letters, I mean. The quadratic formula, we always write it over again. x equals negative b plus or minus the square root. Now, instead of me writing b squared minus 4ac again, we already solved for b squared minus 4ac. It's 25. So I'm just going to write that is actually going to be our discriminant. We're going to put our discriminant inside of here. And you see I'm trying to keep things color-coded so you can follow along. So x equals negative b plus or minus the discriminant all over 2a. Remember, all over means divided by, okay? So now we're going to plug in, substitute values for variables that we see. We bring down our x, because we are solving for x, equals negative, but instead of our b, I'm going to write my parentheses as my placeholder, my plus or minus sign, my square root. I'm going to write my placeholder for my discriminant value. I'm going to put the divided by symbol, 2, in my place value for my a. Then I'm going to go in and I'm going to substitute these values from either my key or my discriminant. And I'm trying to find a different color. Let's use blue. So negative b is negative 3, okay? Now, it's very important that you see that your negative is outside of your b, okay? Minus and negative are not the same thing. And these two negative values eventually will cancel each other out. But I want you to see that we cannot forget that it already came with negative b. We don't go, oh, my b is negative, so I don't have to put anything. Not correct, okay? Discriminant is 25. So I'm going to put 25 into the discriminant's value. And then our a value is 2. So I'm going to plug in 2 here. Boom. So the hard work is really over. You substituted everything into the quadratic formula. Now you have to use your handy dandy calculator, your brilliant brain, or a neighbor. Figure out which tool you want to use. So now I need to continue to simplify, okay? So I have x equals, and I'm trying to keep this in order so you all can see this. Let me come over to the side this way. So again, I start off with x equals. Now, negative 3. Two negatives turn into a positive. So this is now going to be a positive 3, okay? That plus or minus sign, the reason that plus or minus sign is there is because we're taking the square root. Think back to our previous notes in solvings. When we take the square root of something, we have a positive answer and a negative answer. If I had 5 times 5, that equals 25. Well, negative 5 times negative 5 also equals 25. So we can have a positive and a negative option when we're taking the square root of a number. Now, in this instance, we need to take the square root of 25. We're lucky that 25 is actually a perfect square. So taking the square root of 25 leaves us with the value of 5. 5 times 5 equals 25. Negative 5 times 5 equals 25. Sorry about that. Phone almost died on y'all. Then we're going to divide it all by 2 times 2, which is 4. Boom, pretty easy. Now, because that square root is a positive and a negative, we now have 2 solutions. We're going to separate this into 2 different equations. But then we already kind of knew that was going to happen because our 25 was greater than 0, and it said we would have 2 solutions. So now we're going to separate this into 2 different equations based on that plus or minus sign. We're going to have x equals 3 plus 5 divided by 4 equals a number. And then we're also going to have x equals minus, so 3 minus 5 divided by 4. Okay, that is plus or minus. It is positive or negative, but we are using adding and subtracting when it's in our equations. Okay, now we simplify. 3 plus 5 equals 8 divided by 4 equals 2. So one of our solutions is x equals 2. Very important we have x equals 2. Our other solution is 3 minus 5 divided by 4. We got that negative 0.5 in your calculator on the computer. You can definitely change your decimals into fractions. Not saying that negative 0.5 isn't correct, but we want to use our fractions. X equals negative 1/2. And that is going to be our 2 solutions for this equation. And this is where our graph crosses the x-axis. It crosses the x-axis when x is 2 and the y is 0. It also crosses when the x is -1/2 and the y is 0. Okay? And that is how we use our quadratic formula, y'all. So now that you finish this example, I want you to go on to the example problems after solving those, and then another exemplar will come up for you to get some more practice.